Hello and welcome. Thank you for joining Trailhead Live today. My name is Mohit Srivastava. I'm a developer evangelist here at Salesforce. Today, we are going to explore how to successfully create unlock packages. Now, before I begin, there's a forward-looking statement here. Do not make any purchasing decisions based on forward-looking statements. All right, so in this session, the learning objectives are we'll explore what is packaging, we'll understand the dependency concept between the metadata, then we'll explore why do we even need to package up our metadata, what are the benefits of packaging. Then I'll cover what is unlock packages and how do they differ from managed packages. We'll explore org-dependent unlock packages versus org-independent unlock packages. And then, I'll create an unlock package using an application Easy Spaces, which is part of our sample app gallery. And then I'll show you how to configure dependencies between unlock packages. We'll see the behavior of unlock packages when we upgrade the packages. We'll also explore a bit about, the benefits of namespacing unlock packages, when to namespace, when to not namespace, what are some of the best practices around it. Also, at the end, I'll explore some tools for untangling your orgs to modular packages, and then I'll leave you with some reference materials. All right, so let's talk about what is packaging. So a packaging is a container of metadata. It consists of related metadata. So in Salesforce, when you do your code or configurations, you're essentially creating a metadata. Now those metadata can be interlinked. And what package allows you to do is it provides like sort of a container for all your metadata and its related metadata. Now for the package to deploy to other orgs, it must compile and validate. So one thing to note is when you're working with Salesforce DX source format project, you usually map a package to a directory in your project workspace. So when we look at the sample gallery app, we will explore this, how we can map a specific package to a working project directory inside your Salesforce DX project workspace. All right, so this shows an example of dependencies that can be created between the metadata as you do some code and configurations. For example, let's say you create an object and then you define fields. You'll have, out of box configuration, you'll generate page layouts and validation rules. So all these things will be metadata and they will be interlinked. Similarly, let's say you create an Apex class, and then you create a Lightning Web component. Let's imagine that the Apex class references the field on the custom object. And let's say you have a Lightning Web component, which also references a field on the custom object that you have created. So all these create sort of a dependency between metadata, and it's important to understand dependency because if you do not understand the whole concept of dependency, what happens is, let's say you're trying to deploy an Apex class and you do not include the field and the custom object, your deployment will fail simply because the references won't be found. And that applies to any metadata that you have in your org. And that's where packaging sort of helps because you can package up this whole interrelated metadata into one container, and then you can validate that and make sure that it compiles so that you can just install that package in another environment, and that way you don't have to get into errors. Like, for example, errors when you deploy without sort of validating these dependencies. All right, so why do we even need to package metadata? So these are some of the 5 advantages that you get when you package up your metadata. The first advantage is modular application development, which is, if you do modular application development, you can release your applications at faster pace with confidence. So let's say if your org has large number of components, it becomes very difficult to track down these dependencies and iterate on your product. And that's where, splitting them into multiple packages sort of helps, because every functionality that you have, is well defined and has a well established boundary, so that you can actually work on those modular apps and packages and deploy them. The another advantage of packaging up is source driven development. So you'll be able to use Salesforce DX source format. So your package has essentially the same metadata that's there in your Git repo. So that way you adopt source driven development. The other advantage is you build once and deploy anywhere. Now this is particularly useful if you have multiple orgs. If you have multiple orgs, you can build the package once and deploy it. Now, even if you have a single package, you can just build once and then install in Sandbox for, let's say, testing. And then, once you sort of test the package, you perform UAT, you can just deploy the same package to the production with confidence. Now here, when I say deployment, it is installation and configuration of the package. And, what we recommend is, you script your whole workflow, and we'll talk about it as we move along. The other advantages of packaging a metadata is the trackable concept. So because you're organizing your metadata into packages, they can be easily tracked. So you can go to the setup menu in Salesforce and see the packages that are installed in an org, and then you can click through them and see the set of associated metadata. The other advantages of packaging up the metadata is adoption of CI/CD with Salesforce DX CLI. So with this, the change management is more streamlined and creation of packages can be scripted using Salesforce CLI. So these are the advantages of packaging up your metadata. Now, all the metadata that are supported is shown in metadata coverage report. So you should always refer to metadata coverage report. Now, all the metadata that can be included in the unlock packages are shown in the metadata coverage report. So by looking at the metadata coverage report, you should be able to figure out which metadata elements sort of make sense for packaging it up. So metadata that is supported can be easily packaged. For the other ones, you can still adopt org-driven development pattern, where you can use some of the tools like metadata API using Salesforce CLI, or you can use chain sets to move those metadata. Now, there are certain metadata for which even the metadata API is not available. So for that, you'll have to use a document to track them down and then move them or repeat them in production. All right, so before I actually kind of deep dive into unlock packages, let's explore okay, what are the differences between unlock packages versus managed packages? So traditionally, Salesforce sort of provided managed packages for ISV partners. So ISV partners can build these managed packages and list them on AppExchange. Now that was allowed only for ISV partners. Now with unlock packages, the whole packaging technology can be used not only just by ISV partners, but they can be used now by customers. Now, one thing to note, or the key difference between unlock packages and managed packages, are managed packages in Salesforce have IP protection built into them. So they are primarily meant to be deployed to multiple Salesforce environments, while unlock packages are primarily designed to address the packaging needs of enterprise customers. So let's say if you're building an org-specific solution, then unlock packages are a great fit. While with 2GP managed packages, which are meant for ISV, you get additional features like push upgrades, ability to manage the license using a tool called LMA, and then list various package versions on AppExchange. So, note that the unlock packages provide us the ability to sort of use the packaging technology for enterprise customers. And the benefit of this whole packaging, I've already explained, we get a lot of benefit. One of the benefits is modular application development, which sort of makes application development easier. It supports agile driven development. You can release your application with confidence. All right, now before I actually get on to hands-on, we try to take a project and see how we can create packages out of the project. I want to make sure that we talk about two different flavors of unlock packages. So we have org dependent packages which are in beta, and then we have unlock packages, org independent unlock packages that are in GA. Because you already have a lot of metadata in Salesforce environment, we understand that untangling these metadata into packages might be a daunting project. So that's why the team came up with org dependent packages, where the metadata validation can occur during a package installation. So the packages that are org dependent depends on actually the org. So we recommend that you use sandboxes and features like source tracking of the sandbox to build these packages. This is specifically helpful if you have a large org where you have lots of metadata, and untangling them into small modules is a project in itself. So for those type of things, org dependent packages are useful. And really the process of creating org dependent packages and the regular unlock packages are very similar. All you do is use one flag, and I'll talk about that when we actually get on to hands-on. The feature that's specific to unlock packages is the unlock packages can depend on other packages. While if you're designing an org dependent packages, you will notice that the package cannot depend on another package. Instead, it just depends on the org. All right, so now we'll see how we can sort of create an unlock package using an application that we have on our sample gallery app. The application is Easy Spaces. So we'll clone the project, and then we will see how we can create unlock packages using Salesforce CLI, and we'll explore different commands. And we will also see how we can establish dependencies between packages. All right, so we're going to use an application called Easy Spaces. The application is part of the sample gallery apps that we maintain. And you can explore all other apps. They cover different aspects of application development on Salesforce platform. So today we're going to explore Easy Spaces, and the primary reason why I picked this application is because this app demonstrates how you can structure your source code for modular distribution using unlock packages. So that's why I picked this application. Now, the code for this application is available on our GitHub handle, github.com/trailheadapps, where you can clone the repo, explore, and possibly if you could see something that you can add to it, feel free to raise a PR against these application repo. I'm going to pick the Easy Spaces LWC application, and we're going to clone this project. So I'm going to clone this project, and probably I can clone this on my desktop for now. Let me blow up a font. Okay, so I'm going to clone this application. Right, and I'm going to cd into the application folder, and we will explore this application. Now, important thing to note about this application is the code or the metadata is divided into multiple project folders. So we have a workspace, and then as you can see, what we have done is all the objects that we need for this application is sort of bundled in ES-based objects folder. And then it has all the declarative items that are required for these objects, like for example permission sets that we need, the layouts, the global value sets, the path assistance, and other declarative metadata. Now that all goes into the base objects. Now we have also a folder for styles. So we are using themes. So we have those themes, And then we have some branding sets, and we have some Aura components for our custom layouts. So we have an application page where we have a custom layout, and I'll show you when we walk through the application. So all those things are bundled as a part of styles folder. And then we have base code that sort of depends on base objects and styles. And then it has all the classes that are reusable. You can think of like services and factories. And we have grouped them here. We also have some common base components like error panel or other utilities. And then we have put all our message channel. So message channel you use for LMS, Lightning Message Service. So this application uses that. So that is also grouped under base code. And then we have the actual application sort of residing in this folder, ES Space Management. And that has a dependencies to base styles, objects, and codes. And in terms of packaging, right, so each of these folders will be turned up into a package in its own, and we will explore that. Now, before that, I want to explore this application by pushing this to a scratch org and then sort of exploring this by clicking on the application. So I'm going to showcase some of the application features, and then we will come back to how we can sort of package this up as unlocked packages and how to configure dependencies between these packages. All right, so now let's connect to our Dev Hub. So we can go to command line and just say sfdx authorize a Dev Hub. Now a Dev Hub is available in your production environment. So you can enable that in your production environment. And there's a specific permission set that as a developer you could be assigned, which only gives you access to manage and create packages and create scratch orgs without sort of having access to the data. So you can use that. Now let's say you're experimenting or playing around. You can use Trailhead Playgrounds to enable the Dev Hub. Now what is Dev Hub? So Dev Hub is the org which will be responsible for generating scratch orgs. So think of it as a parent org, and then you can generate as many scratch orgs from that. For developer orgs, we have a limit on number of scratch orgs that you can generate, and then the number of packages also that you can generate from our Dev Hub or our developer org. Okay, so I'm gonna just log into this and authorize my Salesforce DX CLI. Okay, so now I'm authorized. So I have I have authorized this. Now let's see if the Dev Hub is sort of enabled in this org. Now you can go to Dev Hub and see if you have enabled Dev Hub. So clearly in this org looks like I've not enabled the Dev Hub. So if you do not enable the Dev Hub, you won't be able to create any packages. You're gonna get errors. In fact, you'll not even be able to even create scratch orgs, or connect this org and associate a namespace. We'll talk about that. So for now, the feature that I want is enabling Dev Hub. So I want to enable Dev Hub by a simple toggle. Okay, so now I have the Dev Hub enabled. Also, we need to make sure that we can generate unlocked packages and second generation managed packages. In this case, we'll be just generating unlocked packages. So I'm going to enable that as well. All right, so the next step is to actually go ahead and create a scratch org. So the reason why I'm creating a scratch org is because I can push all the metadata from all of these folders and push to a scratch org. I'm going to say command line sfdx and then say create a default scratch org. I'm going to use the project scratch definition.json and just alias, and I want to retain this scratch org only for 7 days. You can go up to a maximum of 30 days. Beyond that, your scratch org is going to expire. That's why it's important to connect this application to a GitHub so that you can always version your code so that the code can be retrieved from the version control. All right, so now we have created the scratch arc, and I can actually open the scratch arc by using this browser icon here, which essentially runs sfdx force arc open command. All right, so now I have the scratch arc. Now this arc does not have our application code because it's a blank empty scratch arc. Now we want to push that. Now before that, I want to make sure you pay attention to one of the files, sfdxproject.json files. Now if you look at this file, this is where we sort of have configured our package directories. So in this case, our base objects project directory sort of maps to a project package called ES object. So we're gonna see about that. We'll soon see how we can sort of generate these packages. But for now, note that all we need is the path and the default. So also notice the order is very important here. So I'm going to get rid of version number, version name, and packages. We will need that when we are packaging it up. But for now, let's just uncomment these. I'm going to uncomment or remove this. Okay, so it's showing an error here. That's because okay. All right, so the next step is to again remove the package, the version number. And we have the dependencies, and again these package aliases do not make sense at this point. So we're just trying to push this code. All right, so okay, so let's see. Why is there is a linting error? Missing property. Okay, all right. So we also don't need dependencies at this point. So let's not worry about dependencies for time being. All right, so now we have the package directories, and it's very important to sort of note that you have to specify the paths and then you have to follow an order. So for example, if I sort of have the main folder where I have the application before ES base objects, this is not gonna deploy because the ES base management application actually depends on ES base objects. So the order is very important when you are pushing to the scratch arcs. Also, one of the things to consider is this default. So when I say default equals true, anything that I do in the org when I run my command sfdx force source pull command, that's gonna by default retrieve the metadata and put it into the directory that has the default true. Okay, so now we have this. Let's push all the source code. So what it's gonna do is it's gonna take the code from a specific path and deploy, and then it's gonna take all the metadata from the base styles. It's going to take all the code and the metadata from base code, and finally it's going to take the metadata from ES base management. So it's going to go one by one and sort of deploy to the org. So let's run the sfdx source push command to push this source to our scratch arcs. So as you can see, it just picked up the first folder, and then it's gonna start the job for the second folder, and it's gonna start the job for the third folder. So eventually so there it is. It has deployed all the components into our scratch arcs. Now it's important that we assign permission sets because with that we have permissions to insert data into some of the objects that's been deployed. So I'm going to go back to our repo here and follow certain steps, like for example assigning the permission sets. So first I want to assign easy spaces object permission sets. So we assign the permission set, and let's assign the space management app permission set. So space objects permission set is to provide permissions for the objects, while for the application we have easy spaces space management permission set. Now the next step is to import some sample data. So I'm going to import them using the data commands. Now we have the data in the data folder, where we have the data in the form of JSON and CSV as well, and we have a plan.json file which sort of allows us to define relationship between data. For example, when I'm inserting contacts, I want to make sure that it resolves all the references to account, and when it comes to account ID. Similarly, we have different plans for market, space, and reservations. These are all custom objects required for the application. All right, so now I'm going to run the second command, which is going to deploy all the data to the org. All right, so now that we have the data here, what I'm going to do is I'm going to see if we can actually visualize the application here. So let's give a refresh so that we can actually see the application. All right, so okay, what's going on? Where is our application? Okay, let's make sure that I have the permission set sort of assigned. Oh, oops, I was on another org. All right, no worries. So this is the actual org. So let's see. I was actually on my DevHub org. So let's close that to avoid confusion. Okay, so here's the application. And the thing about this application is we should see the data as well. So I can click on, so this is a page for reservation manager. So, you can create reservations for leads and contacts from here. This part of the component uses lightning flows. And then we have another page called Space Designer, where you can actually go and design spaces. So we have code sort of go and design spaces. All right, so we have this application. Again, this is sort of modularized. It's built using different modules, and we define those modules in our sftx project.json by having a directory for every package or a module, and then we have the application sort of configured or defined in the package directories. All right, so now that we have this application, let's see how we can sort of package these as unlock package. So we want a package for base code. We want a package for ES-based styles. Also want package for the base code, which will actually depend on the base object and styles. And then we have actual application that sort of depends on all three of the packages. Okay, so so let's go through the journey of like sort of creating these packages using Salesforce CLI. And the thing is, you can actually automate this whole package creation in your CI/CD, so that you don't have to manually run these commands. And I'll walk you through a sample file or sample configurations that we have using GitHub Actions to show you how we automate that. Fine, so let's create the packages. So to create the packages, we will need to define three things. So first one is obviously the package. So we want to specify the package name. So let's say we want to call this as ES space objects. Say ES space objects. ES space objects package. So let's just call it as ES space. And then we need the package. So we're saying, okay, so next we need version number. We say version number. So let's say version number. And so here's the key. When you assign the version number, it's important that you use keywords. Like for example, let's say I want to say 1.0. Next. So 1 is our major, and this is minor, and this is patch, and this stands for the bit. So when you use a keyword like next, when you generate the package next time, you will see that automatically the version will be incremented. So you don't have to like manually maintain them. So that's why you need the version to be specified as next here. And also follow, like let's say you're introducing a breaking change, then you want to publish a new major version. Otherwise, just use minor. If you're doing some minor, or if you're releasing patches, you can use patches. Okay. So here's how. So we have the package, we have the version number, and then we also need the version name. So version name is very important to tag. It's called version name. Make sure we have the right keywords here. So the version name, I want to say, V1 version. Okay. So you need three things. You need package, you need version number, and you need the version name. So these things are required to generate a package. So if you look at our project here, and if I look at the sfdx project.json, that's, we have package, version name, and version number. Okay. All right. So now we can generate the package using the CLI command. So it's very easy to generate using the CLI. So you say sfdx force package. So this provides commands to work with package. So we have different commands to do certain things like package install, or list the packages, or uninstall or update these packages, or create the packages. So the first step we'll be doing is creating a package. So we create a package. So we need to say create package, and then the name of the package. So in this case, our name of the package is ES space objects. So I'm gonna say ES space objects as the name of the package, and then I also need to say T unlocked. Now there are different, so you can also make it as org independent package or dependent package by using certain parameters. So for example, if you want to say org dependent, you will use org dependent. In this case, what happens is the package creation happens, and then the validation happens only when you install. Unlike this command, where the package version creation sort of happens right here, the validation happens right when you run the package version creation command. So first we have to run package command to create a package, and then we create versions out of it by package version command. So here I have base objects, and then we say, okay, it's unlock package, and then we need to provide the path, and the path here is the base objects path. Okay, so now this will generate this should generate a package ID, and notice what happens. So a package alias is automatically sort of populated for you with the base objects, and it has an ID associated to it. Right, so that's our first step of creating a package alias. Now the next step is to actually create a package version. So how do we create that? So we use sfdx force package version command. So we say version, and we say so as to help on it. Again, the version create command is what we will be using, and then it has one more parameter, which will be either you can provide alias or you can provide the package ID. Now, important thing to note here is also that you can protect the package by password. We're not going to do that for time being. We're just going to say package version create, and I'm going to say the package ID. In this case, my package ID is this. So that should be it. Right. So, and also I have to skip the password. So there's a little command called installation key bypass. That way I'll tell that it will not require any password. That's going to create a package version for me. So note that the creation of package version is asynchronous because there's a lot of validation that needs to happen. So it's going to take some time. Okay, so it's verifying the metadata at this point, and you will soon see that it's gonna create. Now I'm gonna allow so that it's gonna take some time. Now similarly, we can also create a package for the base styles as well. So on similar lines, I'm gonna go create package for base styles. Sorry, so I'm gonna come back here. Okay, so again, we have to change the name, base styles, and the version number, again, as I mentioned, and then the version name. So V1, let's just name it as V1 version for this. Okay, so so let's see what happened to our previous package creation. Okay, so as you can see, our previous package is sort of created with a package version ID, and it has the installation URL for us to actually go install this package, which only has this metadata that's there in the it only has the metadata that's there in the base objects folder. Now let's run the same command this time to create a package for the ES base styles. Say ES base styles. Okay, so now here we need to provide the folder name for base styles. Okay. All right, so this is gonna create the package, and it should be pretty fast because it's just package creation. So you will see a new alias here being added. It takes some time for the files to sort of update itself. It's going to take some time, but if we close that, we should okay, the contents of this file, let's compare. So as you can see, we have the style sort of added as well. So I'm going to just say compare and just use one of these actions to say use your changes and override, no, discard your changes and revert to file contents. Okay, so now as you can see, we have the package aliases sort of configured, and then we should also have package versions as well, but we don't need to worry because we said it's always the next version. So next time if you sort of generate a new package, it will automatically append the numbers for you. Okay, look here that I created a minor version of the package by mistake, but this should also be 1.0.0. Okay, yeah, so let's create the version for, let's just be consistent here. I'm going to say v1 version. Okay, I'm gonna say v1 version of it, and then the same thing. So we say package version create command with the package ID. This time we know the package ID for base styles is this, so I'm gonna change this. All right, so now we create the package for the ES base styles. All right, so it's asynchronous, it's going to take some time. But now the key is, okay, so for the next one, I want to specify dependencies. And this is where specifying the dependencies will make the package sort of dependent. So the dependency is sort of validated when you're creating the package and also when you're installing the package. So let's see how we can configure the dependencies. So first we will need all these things. We will need package. In this case, I'm going to say it's a base code package. It's version 1, but then I can also specify dependencies by using these dependencies. I'm going to say dependencies, and then we need to specify the dependency by so the dependencies can be specified by, okay, so we need package and the version number. Okay, so we need the package. So let's see. So exactly, we need the package. So in this case, our package is ES base objects. That's our first dependency. And the order is also important when you specify the dependencies. Otherwise, you might run into issues. And the next thing is the version number and the version number of that. Okay, so here's the key, right? So when you're specifying the version number, you can use the key called latest. Using the latest would mean that always whatever is the latest will pick it up. So you don't have to like sort of manually again provide a version number. Now you can manually also provide the version numbers, but it's always recommended that you use keywords like next and latest, because that way next time when you're creating the package either manually or through the CLI, it will be automatically taken care of. So that's the first dependency. The second dependency this has is on styles. So we can do that as well. So by saying depends on the base styles thing. Okay. So now let's see if the styles has been generated, or the styles project has been sort of package has been generated. Oh, did I issue another command? Okay. Okay, I did issue another command for package creation, which is not correct. Let's see if there's already a package that's generated here. Okay, yeah, so we have the packages for the base styles. Now similarly, you can issue a command to sort of generate a package for the base code, and we have to configure the same thing as a dependency. So for this one, we have dependencies on all of these, so I can configure that dependencies here. So configuring dependencies, again, it's pretty simple. And yeah, so I'm going to leave that as an exercise and sort of not cover, but essentially it's the same. So you specify the dependency and then you go through the same commands that I went through for package creation, and you'll get the package for installation. So you can actually say force package versions, package version, and then you can list them. So this will list all the versions, right? So we have, so I issued these 2 times, so I see that, but really you see there are 2 packages already created, and everything will have an installation URL as well, which you can we can even issue a command with more details using verbose. Should give us, so this will also give us the URLs to actually install these packages in another environment. So that's how you sort of create a package and also its dependencies. All right, so we saw how to configure dependencies between unlocked packages. So dependency between two unlocked packages associated to the same dev hub can be easily configured, by specifying the dependencies in the package directories. Now, imagine that you have a project, an open source project that you're sort of downloading from, let's say, a GitHub, which publishes that package as an unlocked package. Now let's say you're enhancing that. So definitely the package that was created is not created in the same dev hub that you have access to. In fact, you do not have the access to that dev hub. But you can actually configure a dependency between those two packages, which are associated to different dev hubs. So let's say you are building up a package called Reimburse Me, and that has a dependency on a package called Travel Anywhere, and it has a dependency, and the current version of the package is 4.5.0. So you can, in fact, configure dependencies between that. Now, the only difference between how you configure it for the packages, how you configure the dependencies for the packages in the same dev hub versus how you configure for different dev hub is by specifying the actual package ID. So in this case, you had the convenience of using version number and using keywords like latest and using the package name. But here you have to use package alias, and the alias should point to the ID. So with that, you should be able to configure dependency between unlocked packages, which belong to different dev hubs. So that way, any open source vendor can sort of publish their package, on a GitHub and provide you the 40 ID as a part of their SFDX project or JSON definition on the GitHub repo, and somebody can actually take that package and enhance it. Now, the last thing that I want to touch base on is configuring dependencies between unlocked package and an AppExchange package. So let's say you have a managed package, which is published on an AppExchange, where the code is sort of IP protected, but they have provided you certain hooks that you can, use and build on top of it, or they provide you some global Apex methods, or some Lightning web components that you can actually use and extend it. So in that case, you can still configure dependencies between the package that you're building, which will be an unlocked package. So you can configure all that metadata dependency by using the package number. Again, what you need is a package number with a 40 ID, and then your dependency should point to that package ID. So that's so important. Again, it is very, very similar to the previous one that I showed you, where you need to specify the ID, and that way you have the dependency established between your unlocked package and an AppExchange package. All right, now I want to take some time and also show you, what happens when you upgrade your packages. Now you will enhance, you will promote these packages. And then you will upgrade these. So whenever an upgrade happens, there are three choices that you will get. So when you're upgrading, you will have options to pick from these three. So first one is mixed mode, which is the default. So this is defaulted. So what happens when you select mixed mode is, let's say you are deleting a component, as a package upgrade. So those components will be deleted, except if the subscriber has a reference to it. Only the listed components will be deleted, and we publish that list on the website. We publish that on our developer documentation, which will say, okay, there are certain components that we will hard delete it if they are deleted in the next version, unless those are referenced in your org. Now, let's say in your org, there's an Apex class that you have used or extended it, then we will not delete that Apex class. It will be deprecated. So that's the default behavior, where a lot of the components that are listed here, or the metadata types of these that are listed, will be automatically sort of deleted, if they have no references in the subscriber org. And the remaining metadata, apart from these metadata, are marked deprecated. So they will still exist in the org, but they will be marked deprecated. Now, the second behavior that you can configure, is deprecate only. That means none of the components will be deleted when the packages are upgraded. So this is very useful if you're moving metadata from one package to other. You don't want the metadata to accidentally delete. In that case, your upgrade behavior, you can select deprecate only. That means it's going to deprecate all the components that are deleted in the original package. Now, the last behavior is delete. So this deletes all removed components. It deletes everything from the org if the component is sort of deleted in the version that you're installing, except for custom objects and custom fields that do not have dependencies. So if there are custom objects and fields that have dependencies established, then it's not going to be deleted and you will be stopped because there are references to that. So that's how the unlock packages upgrade happen. If you get options to choose, on how you want the things to be upgraded. Now, one thing to note is if, let's say, an admin is sort of modifying your configuration components, and if they do not inform you, the next version is going to override that. So it's very important to sort of bring your admins on, collaborate with them more tightly and help them understand the behavior of these, and if they're making any changes, and if they do not want it to be overridden, they should inform the developers so the developers can take those changes, version it, and make it as a part of the package version. Okay. So the other thing that I want to touch upon is namespacing unlock packages. Now, namespaces are optional for unlock packages. So, really do not use namespace if you're moving metadata from unpackaged metadata. Now, what is unpackaged metadata? So the metadata that exists in the org today, which is not sort of tied to a version or a package version or an unlocked package version, is called unpackaged. It's the happy soup that exists today in your org. So if it is not packaged as a part of a package, if it's just something that you have built and deployed using chain sets, those categorize as unpackaged metadata. So here, do not use namespace if you are in process of moving it, because the moment you use namespace, your field names are going to change, and then you will have to sort of again upload a lot of data and do a lot of data activities. So you do not want to do that. So do not use namespace if you are sort of moving your unpackaged metadata and converting them into unlock packages. Other ways you can use namespace. Let's say what namespace allows you to do is it sort of allocates a namespace to the package. That way there is no collision between, let's say you're bringing another unlock package, and if the names are sort of colliding, you don't have the chances for overriding are minimized. So that's why it's always good to use namespaces. But if you're using a namespace, you will need a dev hub, and you'll need to associate your namespaced org. So you'll need to create a developer org where you will namespace it, and then you will link that developer org to your actual dev hub. So there, if you're using namespaces, be sure to regression test and make sure it works. Now, before I move further, I want to leave you with a couple of strategies for modularizing your org that you have today. Note that taking your org into modularizing what is there today and breaking your org or the happy soup into multiple unlock packages is a project in itself, and it has to be planned sufficiently. It's a project in itself. So I want to leave you with some guidance here. So one of the things to note is there are a couple of patterns that you can follow to sort of untangle your org. The first one is horizontal slicing. So in horizontal slicing, what you do is you basically have packages for all your open source. Then you have packages for your metadata, like objects, fields, permission sets. Then you have packages for your Lightning components, and then you have modules. And the modules only comprise of code. And then you also have, things that you cannot package, and those will reside in the org. Like, for example, process builders. They can be packaged, but let's say you don't want to decompose them today because the admin sort of work with them. You can leave them as unpackaged. Really, the pros of this approach is shared packages for shared metadata, which sort of helps your org governance. And they are less prone restrictions because of inability to tangle objects. And also, the cons for this is large packages that change frequently will add overhead to this entire approach here. The second strategy is vertical slicing. So in vertical slicing, your module is not just only code, it has objects, permission sets, and other metadata. So your base package only has like objects. So here, they are more self-contained, and the dependencies are more isolated. But the cons for this approach is only possible when there's clear set of objects within a module. So that's the real con, that you want to create a packaging strategy such a way that the object is hardly tied up with a package. Otherwise, you'll have to loose couple them. And in these kind of vertical slicing, the governance becomes challenging. So you will have to collaborate more for this. But there has to be a collaboration strategy and a governance strategy in place, before adopting this kind of a strategy. Okay, now I want to leave you with some of the tools, and note that I've called it as unofficial because none of them are actually officially supported by Salesforce. They're more of an open source project, so feel free to enhance them and improve them. The first one I want to call out is the Dependency CLI. So this is a CLI plugin that's been built to help you visualize your metadata and help you break them into different packages. So you can visualize the dependencies between them and see what makes sense for you to move them into unlock packages. Now, what I recommend is you start something small. You identify a set of metadata that you can think can be independent of everything that's there in the org, and you try to package that so that your developers understand the package concept, and you become familiar with the whole life cycle of the application development using packaging strategies. So that's one. And then we also have some app exchange apps to help you visualize the dependencies. And then finally, these applications use metadata component dependency API that allows you to visualize the dependencies between different metadata elements. So you can use that. You can use with Salesforce CLI to execute certain queries and find the dependent components. So again, I want to note that these are all open source projects built by open source community and hosted not on Salesforce, GitHub. But one of them is definitely on our GitHub force.com, and it's a Salesforce CLI plugin that you install, and you use that to find dependency component and generate package XML and try to modularize your application into managed packages. You modularize into different unlock packages. All right, finally, I want to take some time and sorry, I forgot one thing. So now I also wanted now I want to also show how we automate this whole thing using GitHub Actions to automatically generate these packages. So if you go to GitHub and if you go to our workflows, notice that we have a workflow for a packaging here, for a packaging PR. So this workflow runs on the develop branch. So what we do here, as you can see, we create different package versions automatically through the CLI. And the best part of it is the dependencies, and we create all of these and then install these into Scratch arcs as well, and finally delete the Scratch arcs. So that's how you can automate it. You can use any CI tool of your choice and use these commands to because a lot of the commands that we have is driven by the Salesforce CLI, so you can actually sort of automate this whole workflow of package creation, managing dependencies and seeing the dependencies and installing the packages in the order of dependencies. And also, one of the things that we do is we keep updating our project.json with latest dependencies, and also our README file with these various packages. So package URL or the installation URLs, we update README file with that. So that's pretty cool, and you can explore that by visiting our GitHub for Easy Spaces application. Okay, finally, I want to leave you with some reference material. So, we have Trailhead modules around application lifecycle and development models, around Salesforce DX CLI, around our Visual Studio Code extension pack, GitHub, and how you can automate your CI/CD with GitLab. So all of these are available on Trailhead. Those are really valuable resources that can help you understand different aspects of release management with Salesforce. Finally, I want to take some time to thank you. Please do leave any feedback that you have for me via my Twitter handle at msrivastav13. If you have any questions, do also reach out to me via my Twitter handle. All right, thank you. See you next time.